very fundamental problem and a basic problem in the context of simple harmonic motion. So let's read the question first, and then we will solve this. Okay, a particle is in linear simple harmonic motion between 2 points A and B. All right, 10 centimeter apart. So the distance between the two is given to you, and take the direction of from A to B. The sign convention is also known to you, and give the signs of the velocity, acceleration, and force on the particle when it is at the end of A. So first of all, you must understand. We can read the question. As we progress. But I think the first thing we have to learn is how do we look at simple harmonic motion. So I will just give you some fundamentals of simple harmonic motion. So if this is A point, okay, this is your point number A, and this is your point number B. So you have a gap of 10 centimeter, which is given to you, right? So let's see, the gap of 10 centimeter is given to you. This is not being drawn to the scale. This is just 10 centimeters. And now the direction from A to B is supposed to be positive. So let's say I draw this direction, and this is A to B is positive. Okay. So from A to B, the direction is positive. This is very important because a sign convention is used. Now, in a simple harmonic motion, you have a body oscillating, and there are few things which are involved in a simple harmonic motion, which is what? Number one is what is called as the displacement, right? So body moves in a simple harmonic motion. There is something called as displacement, right? Displacement. The second thing every body has is a velocity. Velocity. The third thing every body will show up is the acceleration. Acceleration. Okay, acceleration. And then the next thing a body will have is the force. Okay. These are the four things you focus on when you study a simple harmonic motion. Okay. Now let me just tell you what happens in the case of a simple harmonic motion. If a body is in SHM, right? It is in SHM because of something called as a restoring force. So the force which is being referred to, is basically the restoring force. So you must remember the word restoring force. Okay. What is the role of restoring force? If you try to move a body in a simple harmonic motion, say this is the mean position, you take the body and disturb the body, and the body is moving, in this direction, on the rightward direction, right? The body will experience a restoring force in the opposite direction. So if the body is going towards the right, the restoring force will be experienced in the opposite direction. This is the way. So if you try to, for example, in a real world, if I were to give you an example, you take the example of a spring, you draw a block of mass, and you pull it. So let's say you take this mass, okay, you take this mass of, and you connect it to and let this be your ground, and then you connect it to a spring system, right? Now this is a mean position. If you pull this mass towards the right, okay, if you pull this spring towards the right, the spring will exert a restoring force on you, okay, the restoration. And if you compress the spring, okay, the spring will push you back. So a spring, for example, okay, so to make it easy, let me just draw a vertical mass. So this is your vertical mass, right? So this is your vertical mass. This is your vertical mass, and you connect it to a spring system. If this is called as the mean position, okay, the mean position where there is no external force and the mass is hanging. The weight of the mass, which is mg, right, is getting supported by the restoring force in the spring, which is kx. So x is the amount of elongation which the spring sees when you connect the mass mg. So when the moment you connect the mass mg, the spring gets extended by an amount x. Now this is called the mean position. If you now bring down the mass, okay, if you try to pull down the mass and the mass comes down a bit, then what happens is this. So I will just draw the mass again, right, and this is your mass. The same mass is getting pulled now, and now the spring is actually here, okay. At this point, although the displacement has been downwards, right, the displacement has been downwards, you pull the mass, let's assume from center to center, you pull the mass, the displacement is downward, the force is restoring upwards, okay. So the force will be upward. It's an upward force. So what is the conclusion? That if you move the mass from its mean position in a particular direction, the restoring force direction will be opposite. So the direction of displacement, the direction of displacement, and the direction of restoring force, restoring force are opposite to each other, are opposite to each other. Okay. Also note that if you're trying to bring the body down, the body wants to go back toward its mean position. So always the restoring force wants the body to move towards the mean position, move towards the mean position. All right. So let's, with this basic overview of simple harmonic motion, I have not gone into a lot of detail of the motion itself, but the idea of restoring force is very important. That restoring force is going to bring the body towards its mean position and it acts opposite to the direction of displacement is what is the emphasis of this explanation. Okay. Now let's talk about other quantities which are, for example, velocity. So if a body is moving in a particular direction, and you have to see the sign convention which is given to you and then decide the sign of the velocity. In this case, we know that if you move from A to B, the convention you need to follow is A to B is positive, right? That is the convention you need to follow. So let's get into solving this numerical now, step by step, and then see, what exactly are the answers for these questions.
Right, so let's spend some time in understanding the question. We have to study, if you look into the part A, we have to study the motion at point A, right, which is the extreme point. The part B is we have to study the motion here, which is the B point, right? And then if you look into the part C at the midpoint is the point of equilibrium that I explained you. At equilibrium, the forces are balanced and there is no net force on the body. It's a midpoint. Then we have to study the motion at 2 centimeter from the point B, which is this. If you see this point, this is 2 centimeter from B and you're moving towards A because the arrow is leftward, right? Then you have to study the motion at point 3, not the motion, you have to study velocity, acceleration and force at 3 centimeter from A. So you can see this is a point which is 3 centimeter from A. It is going towards B. You can see the arrow, right? And then of course you can see, last, which is 4 centimeter from B. So 4 centimeter from B going towards A, right? Which is leftward. So I hope this made sense to you. It is important to mark the points before you start studying them and also show these directions, right? Which is arrow, so that it helps you decide based on the sign convention what would be the sign of velocity, acceleration and force. Thank you very much. All right, so let's start solving this now, okay? And we will use the basic concepts which we have learned in our previous videos on simple harmonic motion. This is the only channel in the country which gives you explanation, just not the solution. So don't forget to subscribe. It can change your life. I want to impact 1 million students in the country and across the globe. Good education will mean good jobs for you, a good life for you, and you will be able to live a very fulfilled life. So it is important to get good education and not waste your time. Let's start solving this problem now. All right, so you have and B, 10 centimeter is the distance between them. Okay, then the direction of A to B has to be taken. A to B has to be taken as positive. This is a sign convention we will follow. Positive direction. This is given in the question. I have just copied it. And the question is, what is the signs of velocity? So I will just draw a table. So this is the table of velocity, acceleration and force, right? So these are the tables we can draw, and what we can do is we can write all the points here using what is given in the question. So I will just draw a table and we will use this table to give answers. Okay, so we will use this table. We have 1 2 3 4 5 6, right? So we will have 6 rows in this, and 1 2 3 4 5 and 6, right? So 1 2 3 4 5 6. Okay, let's draw the rows and column. Okay, let's see the first point. What is the velocity? First thing you have to tell is the velocity at the end of the A. So if you look into end of A, if you are here, right, at the extreme points, these are the extreme points. A is an extreme point of the simple harmonic motion. Extreme means the last point. So this is your extreme point. Extreme point, right? Extreme point is the last point. So at extreme points, the velocity is how much? The simple harmonic motion, if you see, the body starts from here, goes till the extreme points, it stops at the extreme point and then turns back. So at the extreme point, the body stops. Okay, so the velocity for extreme point A
will be 0. Next part is, what is the acceleration of the sign? We have to tell the sign, right? So the sign of the velocity, we have to tell the sign. At A, what is the sign of the velocity? So if I hope it is clear. So at A, it is stationary, so the velocity is 0. It was facing away from A, from B to A. So the direct acceleration, it wants to go back at the extreme point. It wants to go back to the mean position, right? So this is the mean position. At A, it wants to go back. And we know from A to B, we have to take it as positive, right? So we have taken A to B as positive, so positive. Force and acceleration will go hand in hand, right? So acceleration is going to be positive. Let's talk into B. Acceleration, it wants to go back, right? It wants to go back from B to A, negative, because A to B is positive. So B to A is going to be negative, right? Reverse, negative. Force, same, right? Force is nothing but proportional to acceleration at the midpoint of AB going towards A. So it is at the midpoint. So this is your midpoint, right? Midpoint. Now at the midpoint, it is going towards A. So which means it is going from B to A. So the velocity will be negative, because A to B is positive. It is going towards A, right? Towards A. So it is negative. And we have to find the acceleration at the point, at the midpoint. If it is going towards this direction, the acceleration is always opposite, right, of the direction. So acceleration is towards this point, so positive, and the force is proportional to. So force and acceleration carry common signs. At 2 centimeter away from B, so it is 2 centimeter away from B, going towards A. So let's say it is, for example, let me just show. So this is 2 centimeters from A. This is 2 centimeters from A, going towards A. So it is going towards A. So let's say it is wanting to go towards A. It is going like this, right? So velocity anyway is negative. Velocity is anyway negative because it is B to A. The acceleration, acceleration is always opposite direction, right? It is all. So everybody wants to go towards the mean position. So it is moving towards the mean position, right? So if you see from B to A, it is wanting to move towards. So this is also negative, right? Because the force is pulling it towards the midpoint, right? If you are moving towards the midpoint, right, which is B to A, you are still negative, right? Then force is also negative because it's a restoring force which is wanting the body to go from B to A. Let's talk about the next part, right, which is at 3 centimeter from A. So let's say this is 3 centimeters from A. Let's assume this point. It is moving away from A. It is moving away from A, okay, and towards B. So it is moving away from A towards B. Okay, if it is moving away from A, then what happens? The velocity is positive because it is moving from A to B. A to B is positive. And then what about acceleration? Since it is moving towards the midpoint. See, midpoint is basically the point where all the simple harmonic motion wants to move towards their midpoint, which is the point of equilibrium, right? If it is moving towards its point of equilibrium from A to B, it is positive because it is A to B. If the body has a tendency to go towards A and the midpoint is in the opposite direction, then you can say that the restoring force is in the reverse direction. But if the body is already moving towards the midpoint, then the force direction is same as the direction of motion. Okay, so here you can see the body is moving towards the midpoint in the question number E, right? It is moving towards B. It is 3 centimeters from A. So assume this is your 3 centimeter. Let's go to F. At 4 centimeter from B, going towards A. So you are at 4 centimeters from B going towards A. If you are going towards A, anyway your velocity is going to be negative because the negative velocity is from B to A. And since you're moving towards the midpoint, so if you are here, which is 4 centimeters, this is your 4 centimeter, you're moving towards the midpoint, right? Anybody moving towards the midpoint, you don't have to worry. You just need to see from where to where. So B to A is again negative, and the force also is going to be negative. It's a restoration, right? So restoration force has to be understood nicely, and the sign convention, only when you're moving away from the mid, if this is your midpoint, you're moving away from the midpoint, the restoration force is in opposite direction. But if you're already moving towards the midpoint, don't worry about the opposite direction. This direction itself is the direction of the restoration force. But in this case, if your motion is in rightward direction, your restoration is in leftward direction. That's the way you look at it. But if you're already moving in leftward direction, then your restoration force also is in the leftward direction because you're moving towards the midpoint. So I hope you enjoyed this video. It's a short and sweet video to help you understand the basics of simple harmonic motion. Sign convention is very, very important in simple harmonic motion. If you don't understand sign convention, you probably will find it very difficult to solve the questions of simple harmonic motion in the chapter of oscillations. Therefore, have a good grasp on the topic of SHM. This is the only channel in the country which is working towards explaining the concepts. We're just not giving solutions so that you become addict and you don't learn anything. We're actually going deep inside the solution to make you understand what exactly is happening, right? So therefore, subscribe to this channel. Do not miss any of the videos. For all you know, most of these questions will be appearing in the entrance examination. The more clarity, the better explanation. Good chance that you will score high and get good rank. Thank you very much for your time, and wait for my next video.